Hello everybody, I would like to welcome you to our 22nd video in the pre-algebra playlist, and in this video we're going to go over how to solve decimal equations, especially those involving addition and subtraction. A few videos ago we went over the addition property of equality as well as the subtraction property of equality. Back then we were only dealing with integers, but we can extend the same addition property of equality and the same subtraction property of equality onto numbers that are decimals. So if you haven't really seen the video on the addition property of equality and the subtraction property of equality, it is under Solving Equations Part 1. And for those of you who have seen it before, I'm not really going to go over it again, but I'm just going to use these properties over here to solve equations that have decimals in them, especially those that have addition and subtraction. So now let's go over our first example. So let's say I have something such as x plus 8.19 is equal to 4.75. The goal of this problem is to solve for the variable x, and in order to do so, I need to find some way of getting x all by itself. Basically, I need to isolate the variable x. Now we know from the previous videos that in order to do so, I really need to move this term, which is plus 8.19, onto the other side of this equation. And for me to do that, without changing the equality of this equation, I can refer back to the subtraction property of equality that tells me that if I subtract the same number from both sides of this equation, my equality will not change. So over here, I need to perform an appropriate inverse operation of subtracting both sides of this equation by the number 8.19. Furthermore, when I simplify the left-hand side of this equation, these two 8.19s basically cancel each other out so that I'm only left with the variable x on the left-hand side. And then on the right-hand side, I am simply left with 4.75 minus 8.19. When I evaluate this over here, I will be left with my final answer. And I leave it up to you to verify this, but the answer will be negative 3.44. So x is equal to negative 3.44. Now in order to solve this equation over here, I refer back to the addition property of equality that tells me that if I add the same number to both sides of any equation, the equality will hold true and it will not be destroyed. So I need to perform the appropriate inverse operation over here that will get rid of this negative 18.2 term over here. That appropriate inverse operation is adding 18.2 to both sides of this equation. When I simplify the left-hand side of this equation, the negative 18.2 and plus 18.2 cancel each other out to give me k all by itself. Then on the right-hand side of this equation, I am left to evaluate 14.187 plus 18.2. Now I leave it up to you to verify this, but 14.187 plus 18.2 will give me a final answer of 32.387. So in this problem I have that if Tom decides to drive a distance of 324 miles and if after 128.79 miles his car breaks down, how many miles does Tom still need to cover? So what we are trying to find are the number of miles that Tom still needs to cover. So we can represent that by the variable s. But we know that he has already covered 128.79 miles. So we can say s plus 128.79 will give me the total number of miles that Tom decided to drive on the trip. In this case, that number is 324. So all we really need to do is solve for the variable s by isolating it. And in order to do that, we need to perform the appropriate inverse operation of subtracting both sides of this equation by the number 128.79. These two terms over here on the left-hand side of this equation will cancel each other out to leave me with the variable s all by itself. And therefore, variable s, or the number of miles that Tom still needs to cover, is equal to 324 minus 128.79. I leave it up to you to verify this, but S will be equal to 195.21 miles. So Tom still needs to cover 195.21 miles. Let's do one more example. So in this example over here, we have Scott has $500 in his bank account. If he makes a certain withdrawal, after which his bank account shows a deficit of $126.12, how much was the withdrawal for? Now in this case, we need to realize that the term withdrawal symbolizes the operation of subtraction because you are withdrawing or basically taking out, also known as subtracting that much amount. Also, the term deficit means negative as well. So what we know is that Scott started out with $500. After that, he made some amount of a withdrawal, which we will denote by the variable W. And since withdrawal means subtraction, we can write that as minus W. After which he was left with $126.12 in the deficit. And since in the deficit means a negative, I need to put a negative over here. Now what I really need to do in this case is to figure out some sort of an inverse operation that will help me isolate the variable W all by itself. And in order to do that, what I can do first is add the term W to both sides of this equation. Next, when I simplify the left-hand side of this equation over here, the W's will cancel each other out and I'll be left with this over here. Next, I need to get rid of this negative 126.12 term over here. And in order to do that, I need to perform the appropriate inverse operation of adding both sides of this equation by the number 126.12. When I simplify the right-hand side of this equation over here, these two terms cancel each other out to leave me with the variable W. And when I add these two terms over here on the left-hand side of this equation, I'll be left with 626.12. So this tells me that Scott made a withdrawal of $626.12 from his account. So that's it for this video, and I hope you keep on working hard, and I'll see you in the next video when we go over solving decimal equations involving multiplication and division.